All right, well, thank you very much for all of you for joining. So good morning, good afternoon, good evening. So it is just gone 9 a.m. my time here in London. And so I work for Single Store, and I've been with the company since roughly the middle of last year. And I'll say a little bit about my background, but today we're going to focus very much around sort of machine learning. So we'll talk about a number of ways that you can work with the technology, a number of integrations, as well as the built-in capabilities, if I can put it that way, in terms of doing machine learning directly with the database system. Okay, so there's a number of capabilities that Single Store DB, the product, supports. Okay, so a bit about my experience then, broad industry experience. So I've been working in IT for quite a long time, worked with a variety of technologies and a number of different roles as well. So I've done everything from technical marketing to consulting. I've also been an academic, what is now the distant past, I guess. And so, you know, with this experience and wearing these kind of multiple hats, it gives you a great perspective on the kind of problems that people tend to have, you know, in many walks of life. So you can understand and empathize with the way that developers struggle, for example, with certain tools, or the fact that as a vendor, you're trying to implement new features and capabilities to help people do their job better. Some of those pain points can be very, very, you know, disconcerting, troublesome. And so what you want to try and do is to make it as easy as possible for people to be able to utilize the technology. You know, this need to have simple to use products and services, powerful, that can accomplish a great deal. So we'll look at some of the capabilities of Single Store today. I've been also very privileged that I've worked on many publications and presentations over the years, and here are some of the sort of publications that I've had in the distant past. I wouldn't recommend buying any of these, please don't. The main purpose here is to show you that, you know, over time kind of technology evolves. So like I said before, I've worked in database technology for quite a long time. And sometimes it's like swings and roundabouts, you know, and ideas come and go. New things emerge roughly every 10 years or so. So many years ago, when I first was as a researcher, object-oriented databases, that was the hot technology of the day. You know, that was going to replace relational. 10 years later, it was XML. That was the big thing. And then today, of course, it's NoSQL, NoSQL. The key point here is the big and the observation that I've kind of made is that over this time, despite the kind of age, if I can put it that way, of relational and SQL-based systems, nevertheless, I mean, these systems are very mature now. They are well understood. People know how to build good optimizers. There are many tricks and techniques that can be used and deployed in modern relational systems. And of course, they've evolved as well. So now you've got to the stage of distributed SQL sort of database systems, of which Single Store is a great example. So the key thing is that, and again, if you've looked at the results from the recent Kaggle, they published survey results. SQL and Python, I think, are two of the most widely used technologies as far as data scientists and machine learning engineers are concerned. There's a lot of mileage still to go, and SQL is going to be with us for a very, very long time. Okay, so the goal here today is then just briefly introduce Single Store, say a little bit about its kind of architecture, some of its strengths, capabilities, and literally the cloud-based version. I mean, you can sign up and you can be using it within a couple of minutes. They don't ask you for a credit card either. I mean, you get a certain amount of credits free of charge to get going. And if you are kind of prudent and use those well, you can keep going for quite some time. Just an FYI, so when I joined the company, I signed up for a free account just before, and I still have credits even today. Okay, so that's something that I use from time to time. So that can, you know, give you a lot of mileage. What I wanted to do in particular is that the number of slides I have is not that big, but I wanted to give you much more in terms of the integrations and show you some live coding to show you how easy it is. Now, obviously, because of pressures of time, I can't go into a great deal of depth. I can't show you something very elegant and large scale. Nevertheless, there are one or two data sets that are very popular, well known to you. Probably you've used them yourselves, and we'll make use of those. The thing is that whatever I use can be scaled up. It doesn't matter. I mean, these are just examples. So literally, you can substitute your particular data set, and it will be absolutely fine. Okay. So Spark is one of the technologies that I wanted to demonstrate. Also, similarly with the Python client, for example, you might be using scikit-learn, PyTorch, or something like that. SingleStore has these built-in vector functions as well, which literally you do the in-database kind of machine learning. So things like Euclidean distance, for example, or you can use dot product. These are built-in, and you can run it on the data. It's not something you have to code yourself, but you just need to know how to use them. I've got an example of one of these that I can demonstrate to you. MinesDB is also one of the partners of SingleStore, and they have a very interesting kind of AutoML technology, which is very, very nice. It's kind of based around SQL. So if you are a strong SQL developer, you have strong SQL skills, I mean, you can hit the ground running and be working with that very, very quickly. And again, I'll show you the integration for that and how easy it is to be able to utilize that and create some models and get some predictions. And finally, the best thing for last, I guess, if I can put it that way, WebAssembly. So this is something that you may have heard of in the context of perhaps running things within a browser. But this technology is now really expanding into a number of different areas, one of which happens to be the ability to take some existing code that you might have, say in C, C++, or Rust, for example. Perhaps you coded some wonderful algorithm, and you can now create a module of that, have that executed directly within the database system. And I'll show you an example of some sentiment analysis on some movie data. And this is using something called VADA, Valence Aware Dictionary and Sentiment Reasoner, I think is what it stands for. So this is going to take some existing Rust code. We'll load it as a function within SingleStore, execute it, and run it on some data that we've got from some movie data, and that gives us the ability to extend the core engine in a safe and controlled way, because this runs within a virtual machine. Okay, so this is really kind of exciting stuff, because what it means now, excuse me, is that essentially if you've got some code or you've got an idea, you can now code that up and have the database engine manage and execute that for you. So this is really going to be, I think, very, very relevant and very useful for the future. We'll try to keep everything as much cloud-based as possible, and the environment that I'm going to use in terms of running my code is called DeepNote. You may have used it yourself. It's a great kind of Jupyter-like environment based in the cloud, and I'm simply going to connect to my SingleStore cluster, which is running at the moment. And for the WebAssembly, I had to do a little bit of work locally in a virtual machine, and I'll show you the code for that momentarily. But apart from that, everything else is cloud-based. It just makes life so much more simpler and easier, because all of us have particular software and configurations on our laptops, which sometimes makes it difficult to get stuff working properly. I've experienced that a lot over the years, and therefore, doing it in a cloud-based environment just makes it a lot simpler and easier, because there is nothing to kind of impede you in terms of your productivity. Okay. So a little bit about SingleStore then. So it's a real-time distributed SQL database. So as I said before, SQL has come a long way from its origins many, many years ago at IBM. And so today we have this notion of distributed database systems that can run SQL. So this idea that, essentially, with the ability to divide and conquer, we can manage our data across a cluster of machines. We can scale horizontally, so there is no need to buy a bigger box. You know, you don't have to buy a bigger server in order to scale up. Now you just add hardware components as you need, and you scale horizontally. It can store the data, it can add the processing, and this is really coming from the world of distributed systems, which have been around for some time, and I guess the NoSQL guys introduced this kind of idea, but we've been extended into the SQL world as well now. So single store is an example of a distributed SQL database. The other interesting feature about it is this unified data engine. So historically, where it's come from, it was an in-memory database system, and not having to write to disk, you keep stuff in memory, just access it very, very fast. Great for online transaction processing. However, you know, the world kind of moves on. People want to do analytics as well. Different kettle of fish. I mean, it's a totally different problem. So there you're dealing much more with kind of columnar data, okay? So you want to be able to do things like sum, min, max, average, count, and you want to be able to do that very fast. And so single store can do that as well now. So it combines both of these capabilities, the ability to do OLTP workloads and the ability to do OLAP and data warehousing workloads as well, okay? And that's one of its unique selling points. What I would say is that, you know, there is an old phrase, imitation is the sincerest form of flattery. So single store has been doing this for a little bit of time now. Others are trying to copy us, but, you know, come to the source. This is the original. Here is a kind of a 30,000-foot high-level view of the technology. So let me just try and get my arrow here. There we go. So we've got the in-memory, okay, and we've got the disk space column store. Okay, so these are combined in this product, and it can be used for a variety of different applications, which we see at the top here. Okay, so real-time decision making, IoT, dynamic experiences, as well as the analytics, you know, creating dashboards, ad hoc queries, and the machine learning, which is really our focus today. The other thing is that it is a multi-model database system. So yes, very much relational is at the core of the technology, but in case you have other requirements, it can handle geospatial, okay? It has a built-in full text search engine as well. It can do time series, can handle JSON data, and even if you want to use it as a key value store, that's possible too. It is offered in a number of different flavors, so depending on where you want to run it, you could do it on-prem, okay? Managed database as a service, okay, which is, like I said before, you can literally sign up for this in a couple of minutes. You could self-host and even containers if you want to, okay? So there's a variety of different ways that you can use it. In the event that you would like to install it yourself, there is a free 4-node license that you can get. So you can literally get software, and it's up to you where you want to run it. You know, if you've got your own cloud-based environment, or you want to use one of the providers, cloud providers, to be able to do that for you, that's absolutely fine. We have customers that are doing that as well. Okay. Excuse me. Key things then that make it unique. So this universal storage, which I've already mentioned, single table type for transactions and analytics, point in time recovery, okay, that is very important, okay, particularly if you plan to do this, you know, a lot of important transactions that need to be guaranteed that things are correct. In the event there's some failure, at least you can roll back and restore the system to a good and known state. I've heard of cases where, for example, you know, mistakes by developers have caused some problems with production environments. Fortunately, things like point-in-time recovery allow you to roll back to a known good state. That is very, very useful and extremely important in production environments because, you know, downtime, you're losing money. Speed, fast transactions for analytics, a whole variety of technologies that are used there. Again, because of lack of time, unfortunately, we can't go into the detail today. One of the very useful features that it also provides is this notion of pipelines. So literally, it can ingest in parallel. I've done examples using Kafka, and you can do like S3 buckets as well. For example, you've got data, large quantities of data that are sitting there, and you can create these pipelines to be able to read that in parallel and ingest it into your cloud-based environment. Very useful. Unlimited storage, separation of storage and compute. So this is a concept that's come about over the last couple of years. The ability to, particularly for data warehouses. I think that the concept's been around for a while, but really we haven't seen it used very much in the world of data warehousing until the recent past. Now there is this notion that Single Store coined this phrase, bottomless, in the sense that, have as much storage as you want, and the compute is entirely separate from that. We've talked about the multi-model. Okay, we've talked about the fact that it can run anywhere. And one other very, very useful capability is this ANSI SQL, MySQL, MariaDB ecosystem. So it is MySQL wire compatible, which means that all of that world of MySQL tools that you use, the drivers, anything that can plug into that can work extremely well with Single Store. And I use that a lot. So there are many cases, for example, Apache Superset, for example, or Airflow, where I've done examples. I've gone in, simply be able to select MySQL, and it will work just fine with Single Store as well. So that is something very important. And again, your skills, if you have them in the MySQL or MariaDB world, will translate and transfer very easily across to Single Store as well. Okay. This is a very nice kind of large picture, if I can put it that way. And today our focus is very much over here in this kind of space, if we can see it. And I know these icons are a little bit small, but as I said before, we will look at Spark, and we'll look at MindsDB as two examples here. But as you can see, there are integrations with many other tools there. Looker, Sisense, Apache Superset, Tableau, and so on. Maybe for another time. Okay, so that's enough of the slides. Okay, so let's actually have a look at some of the integrations at work, and let me just minimize this for a moment. Okay, so we'll come back to this a little bit later on, just to wrap up. Okay, let me just scroll down here a little bit, and let me select the other window then. Here we go. Okay, so as I said before, I'm using DeepNote as my notebook environment here, simply because it's cloud-based. I happen to like this very much because it's super easy to use and allows you to create a number of integrations by yourself. So I've actually managed to set this up with a MySQL one for Single Store, and there's a MindsDB one as well, which we'll look at very shortly as well. And so the first thing here is, as I said before, because I've got 5 examples to show you, we can walk through these very quickly. So the first thing we'll do here is, let me see if I can make this perhaps a little bit bigger. So zoom in a bit more. See, there we go. And this one is going to just simply install Spark in my environment. Okay, so now, oh, there you go. Let me just refresh this. Run this again. I think it's been idle for too long, that's why. So let me just refresh the page and try again. Hopefully we'll get it working. Oh, there we go. That's it. Let's try it. There we go. And if you're sharp-eyed, you can see here, it says here, it's starting up the machine. Okay, so it just takes a moment or two. It's been idle for a little while. And so it's just setting up the initialization there. There we go. And so first thing it will do here is just install Spark for us. Okay, so this is the open source version rather than the Databricks version. So Databricks does have its own notebook environment, and I think you can create a community account, and they still offer that. But this is fine too. Okay, so just give that a few moments. This is a one-time operation. Okay, the rest of it is I think there's only one other point in the notebook where we have to just wait a little while for something to complete running, but this is almost done. So this is just installing PySpark version 3.2.2. Okay, and that's done. It's we've got a green check mark there, as you can see. Okay, there we are. So that's finished executing that cell, and I'll scroll down a little bit here. Okay, we need to create Spark session. And for here, what I need to do is a couple of things I have to add here. So there is a single store connector for Spark here. I also need the JDBC client, which is here, and we need spray JSON as well. Otherwise, we don't get any output. So just these three things need to be added, and they are just stored in a local folder here on the right-hand side, just over here. Let me just try and show you here. Okay, so I've got the ability to create folders on this side. One of them's got data, the other contains the jar files. So let me just execute this. Don't worry about these warning messages, it's fine. Okay, so that's complete. We've got a green tick mark. So that's all done, and there we are, we're all set. The main thing here then is that in order to talk to single store from Spark, the data structure that you are that I guess you're most familiar with is the Spark data frame. Okay, so this is what is used to communicate between Spark and single store. So we simply need to point to the server itself and the password. I realize you can see that. That's okay. I mean, this is just temporary. It's going to go very soon. And so I just need to provide a little bit of information about what is the location of the cloud-based environment that I want to connect to. What's my password there, the port number, and if we just execute this, there we go. That sets us up. That's green tick mark. That's all done. We need to just set up a few of these configuration parameters here as well. Okay, and so it's mainly what is the endpoint, okay, which is the cluster information just above. Who is the user? In this case, it happens to be admin. Okay, that's the default that I'm using there. I provide my password as well, and this concept of pushdown. So pushdown is very useful because what it does is that when, let's say in your Spark environment, you might be using mlib, for example, or you might be creating some data frames, or you might be doing some SQL queries, and you are targeting some backend database system that you're connecting to. You know, either you're pushing some information there, or you're retrieving it. And so the Catalyst optimizer on the Spark side, if you are talking to a backend database system, it's kind of smart enough to know that, oh, you're running a SQL query. I don't know enough about that. Let me ask the backend database system to manage that for me because it knows far more about the data than I do. And so this is a very useful feature because essentially the backend database system will then evaluate that query for you much better, and you'll get the result back that you need. And Spark kind of offloads, if you like, the work to the database system. So currently this pushdown is enabled, okay, which is exactly what we want, but you can disable it. And that's all we need. So now with just these two cells, we've got our environment set up. We're ready to talk to single store from Spark. So let's read some data in and just simply create a simple Spark data frame. We're just going to read in a CSV file here. We're going to infer the schema. There is a header as well. Okay, so that just reads it in. Again, this is just stored locally. Okay, there we go. And we can take a look at the data frame. You know, how many rows do we have here? Okay, so 150. This is the iris data set. Okay, I mean, you're probably very familiar with that. Let's take a look at 5 of these. There we go. And there you can see it's showing us 5 rows. So that is part of our Spark data frame that we've just read in. Now, at this point in time, you've got some data, you've got the Spark running, you have a data frame that's created, and you probably want to do some exploratory data analysis, have a look at the data, for example. these are just very, very simple examples here. Okay, so we just do a count, group by the 3 different species of flowers that are stored there, and we have 50 counts of each of those. And again, we can take a little bit more of a breakdown in terms of getting a bit more information about what is actually going on here. I apologize, the notebook seems to jump around a little bit whenever I hit the return. There we go. So we got mean, standard deviation, min, max, and so on. I mean, you can think about other things that you might want to do in this particular environment. One of the things you might want to do is just simply plot the data. Perhaps you want to do some principal component visualization. Okay, and there we go. Just create a chart here. And similarly here, you might want to do sort of a heat map just to get you some idea in terms of the correlations. There we go, and so on. Okay, do some analysis of the data, do some exploration, get some visualizations created, and so on. And when you're ready, okay, you can take that data frame and we can write it directly into single store. And notice that I didn't have to create any table in single store. What this will do for me is it will create that table for me. I can provide a couple of options here. Okay, compression. In this particular case, I'm just saying overwrite. So if it already exists, it will overwrite what's already there. Perhaps you don't want that behavior, you can change that, that's fine too. And then simply, what's the target? Where is this data actually going? It's going into the demo database and this table called iris1. Okay, so if I do this, don't worry about, again, this warning here. It's simply because the table doesn't exist, and therefore it's giving me that warning. So if I were to run this again, because I've got overwrite, you'll see that it will run and that error message is gone because now that table is already there. Okay. And similarly, we can read back the data from our cloud-based environment into this notebook. So we can do the reverse if you like. Again, tell it that the format is single store. Where is it coming from? It's coming from the demo database, the iris table, and we can read that back in. There we go. And again, just for safety, we can read how many rows, 150, show us 5, and there we go. Okay. And if I were to, let's just have a look here. I think it's, make sure I've got the right one. It's this one. I'm sorry, I'm trying to find the, let me just have a look here. There we are. Eventually got there. Okay, so this is actually my cloud-based single store environment. So I can run this query to just show me the databases. Okay, and so one of the databases I have here is called demo. So I'll tell it, use demo, and then show me the tables here. Okay, and you can see down below here, iris1. Okay, and if I were to select star from iris1, execute this query, there we go. And there you can see just down below here that it's giving me species, the petal length, and so on. Okay, and there's over here it tells me there's 150 rows. Okay, it took 277 milliseconds to retrieve that. So there we are. So that is the cloud-based storage. This is the single store side that's actually being used. And there you can see that the table was correctly created. So the data went in, and I was able to pull it back out again. So, like I said, number of benefits because the integration is tight. I can use compression. I use the data structure that Spark understands, and I can read and write directly to single store. And so if I'm working in this environment, maybe I want to do some machine learning, perhaps I want to do some analytics, directly from my Spark environment, I can do that and connect to single store and do so in a very seamless way. Couple of lines of configuration, that's all I needed, and then it just needs to know where that environment actually lives. So very, very easy, very smooth integration. Okay, let's move on quickly. Have a look at the next one, Python client. This is super easy to do. So just import single store DB as S2. Okay, there is a requirement that set it up. I didn't need to do the pip install. Again, just set up the connection from this Python environment here. I need to tell it where the host is, the port number, who is the user, what's the password, what particular database I'm looking at. Okay, we set up the connection. And what we're going to do here is simply read from this CSV file again, same one that we used for our Spark data frame, but this time we'll just create a pandas data frame. Okay, and again, we can take a look. Structure, how many do we have? Well, total 150, no missing data there, so that's correct. And again, we can just do this head 5, just take a look at 5 of these values. And again, you can see it's very similar to what we saw previously, so that's fine. We can do a preparation here for an insert statement. So here we simply have these values going in. Okay, so if you've worked with embedded SQL or you've worked with JDBC, for example, this kind of thing should be very familiar to you. And then very, very simply here, we simply say, take this connection, create this table. Okay, execute this, take the data from that data frame, okay, and apply the statement that we just created above, the insert, and that will all be done as part of this with connection operation. And then just immediately afterwards, what we'll do is, once that's run, we'll actually pull the data back again by doing a select star, and it will store it in this variable called rows. So that's a list of tuples. That's what we're getting back. So we're writing directly into single store, and we're pulling the data straight back out. Okay, so let's just run this. There we go. Now, in order to do something useful with this, again, if we want to do some exploratory data analysis, for example, easiest thing to do is just create a pandas data frame from that. Very easy to do. And again, exactly the same thing as we did before. We could do some Plotly, for example, PCA visualization. Okay, there we go, just above there. Or the heat map that we saw earlier as well, exactly the same thing. And by the way, if you want this notebook, okay, just let us know, okay, and then I'd be happy to send that to you. You'll see, again, because of lack of time, but you know, we don't have the time to dig into this, but these results should be identical to what we previously saw. Okay, great. Let's move on. Vector functions. So one of the capabilities that single store has is this notion of these built-in functions, which actually cover a wide range of uses. But there are a couple of very good ones that would be very applicable to data science and machine learning. So one of them is this Euclidean distance, for example, which is one of the ways that you can measure, you know, whether two things are close to each other. Are they sort of similar? And so here, what I'm simply doing is creating an integration so that I can run SQL commands directly within a cell rather than having to wrap it up in some way, you know, either in a Python statement or having to send it across as a data frame or something like that. So now I can just execute this directly. So we'll simply create a table with two columns. One is a vector, and the other is the actual species. So you can guess that the vector consists of the other four columns. Those values will constitute the vector. So we'll just run that. It has done that. And then the next thing we'll do is just insert the values. Okay, so we're using this thing called JSON array pack. Okay, let me just again try and just drill down here a little bit to show you. So we've got the 4 values: sepal length, petal length, and so on, petal width, and then finally the species name separately on the outside here. Okay, so there's 150 rows that we're going to insert. There we go, that's gone in. And then what we'll do then is the very last row that we entered, the values of that here, we are going to take those and then we're going to query the system and then ask it, tell me what you think the species of that is based upon these values here. Okay, the Euclidean distance is 0. Okay, that's what we're trying to determine. Is it identical to what went in? And it comes up with this answer here, Iris virginica. Okay, and if we scroll up and just take a look at what the very last value was, indeed it is that one. There we go. Okay, this has somewhat more utility though. So the other thing is that what we could do then is say, okay, well, rather than just comparing against a single value here, why don't you just show me the 5 nearest ones to this as well? Okay, again, using this Euclidean distance. So if we run this, 1 is an obvious match. It's identical, okay? Hence the distance here is 0. Okay, and this is the value that we just obtained a moment ago. But then it's given me these other 4 as well. Okay, so you can see again, it's calculated the Euclidean distance. And again, if we check back and have a look at the data that we previously added, we should be able to find the relevant rows. We can make a prediction. So we can add something hypothetical, some value that we don't previously have. So this is just a set of numbers that doesn't actually exist in the data set, but we've just pulled some values out here, and then let's see if it can make a prediction based upon these and then show me what it thinks that is. What's the species? So I just run this and it's given me a prediction that it thinks that it's this, Iris setosa. Okay, and actually if you try this with other packages like scikit-learn, for example, or other machine learning packages, and you do the similar sort of thing using these kind of values, it will make the same prediction. Okay, so that's pretty good. The other thing is there's dot product, and so if you want to do things like alternating least squares, you want to be able to make predictions such as what movies people like, for example. That's one of the examples that I worked on some time ago. That's a great way to do it. Again, you can store these values directly inside the database system. It can do the dot product for you directly within the database system, and then it can give you the numbers. Then from that you can decide and order them, how close they are, how close is the match. Also very useful for image recognition. I think that's one of the applications that comes to mind. Okay, 2 more quick ones. I realize we're kind of moving on in time. So let's have a look at the MindsDB integration. So as I mentioned, this is a great example of an AutoML tool. So we can start off again by creating another Iris table. This is number 4. Okay, so we've created a few already, and this is another one. Same database. And this time our insert is sort of fairly standard, as you can see here. These values, we didn't do any JSON array pack. These are just standard floating point values, as well as the actual species name. and we'll just store these directly in. Okay, so there's another 150 rows gone in there. And we can take a look. Just execute this, have a look at five of these. There we go. Okay, so again, this should remind you of the pandas data frame, the Spark data frame. It's all come out in nice kind of rows and columns, same sort of thing. It's just picked five values for us. One of the things that we can do then, here you can see there's an error here, simply because it's trying to delete something that didn't exist. Now, because I've run this previously, I think this won't happen. Okay, so let me just execute this so it kind of clears it and gives me a clean slate to start with. So with MindsDB, essentially what I'm able to do then is to create a database. I can specify the engine that I want to use. In this case, it happens to be single store. And again, I provide some details about where is the location of the system that I want to utilize for this. So you can see I provided my credentials, my username, my password, the cloud-based host, the port number, and the particular database that I want to use. And from that database, MindsDB will create its own kind of database here. Okay, it takes a moment or two. Let me just execute that. There we go, that's done. And then from the MindsDB side, remember we just did this a few moments ago. From the single store side, we'll do the same thing. Take a look, get back 5. And again, same thing here. You can see rows and columns, very similar to the pandas data frame, Spark data frame. All right, now what we can do here is, again, because I've run this previously, I'll drop this predictor. Let me just do that first, okay? And then we'll recreate it just below. So here, very kind of SQL-like construct. Okay, you can see the language, the kind of style of how you do this. What we're asking it to do is that we want to predict species. And so we're asking it to create a model based upon that. And if we run this, okay, there we go. And we can take a look at the predictors. Okay. Now this is where it slows down a little bit. Okay, so what it is, it takes a little bit of time. Currently, it's training here, right? There's nothing for accuracy, nothing for species. So basically, it's thinking about it, right? It's figuring it out. It's creating this predictor based upon analysis of the data, which is not very large. It's only 150 rows. But I'm asking it that I want you to take the data that I've provided for you, and I want to be able to predict a species. Okay, so if we run this again, let's see if it's finished. Okay, still training. Okay, it's, like I said before, it's a little bit slow. You'd think that for 150 rows it would be a lot faster, but there we go. I mean, let's try again. See if it's going to finish. Okay, now it's complete. There we go. Okay, so it's complete, and incredibly, we've got an accuracy of 1.0. So basically, it's created a perfect model, which if you actually repeat this, okay, if you do this several times, you'll see that the accuracy isn't always necessarily 1. Sometimes it's like 0.99, sometimes it's 0.87. All right, it's just the way that this works. So that's the model that we've got, and then we can get a little bit of information about this. You know, give us some info on the model itself. Sorry, apologies. This keeps jumping around a little bit. I think it's because I've set the view for the browser to be quite large. And so the output that we're looking for is the species. and then you can see what it's using in terms of the inputs: sepal length, sepal width, petal length, petal width. Okay, and then again we can get a bit more information about what features. There we go. And so you can see that here our target is the species. Okay, that's what we want. And then the other 4 columns are being used as the features in order to help us get there. There we go. So this kind of thing is, as you can see, it's SQL-like. It's kind of extensions to SQL. And so, there's not a lot that you need to be able to do. Basically, because it's AutoML, it goes away and does all the hard work for you behind the scenes. You don't have a lot of control, but not this way anyway. I mean, if you want to have much finer control, there's other ways to do this, but this is a good start. And then we can just simply ask it to make a prediction here. Again, I've got some fictitious values here, same sort of values that I used previously, same numbers here. I'm just saying that, okay, take these values, and what do you think is going to be the species based upon this? And in using the model that you've built, tell me what you think that is actually going to come out to be. There we go. And it says with an accuracy of 0.75 that it thinks it's Iris setosa. So, and then what we can do then is to say, well, okay, let's compare your predictions with the actual values and see how accurate you were. Okay, and we can then, rather than having a sort of 150 rows to look at, let's just look at which ones didn't quite match. All right, so it's come up with 5 here. Oh, let me just try and do that a little bit better. There we are. Okay, where it actually predicted one thing, but the real value was something else. And it's usually virginica and versicolor. And I think the reason for that is that if you look at the plot, you'll see that those two are very close. If you do something like a principal component analysis, or even just do a sort of a plot comparing, petal and so on. We could do a heat map again, just a sort of confusion matrix, and we can see that in fact the errors here, okay, it's the 3 mismatches and then 2 here, which are the 5 in total. So as I said before, if you rerun this a few times, you don't always get the exact same result. Okay, I mean, it's just one of these things. All right, so we are almost out of time. So last thing, last but not least, WebAssembly. Okay, so here, let me just switch to my virtual machine. Okay, and there are some steps that you need to go through in order to create this, but essentially what you have, or what I've done, is simply created an interface definition here. So I'm saying that what I want to do is to create a function. The function takes a string as a parameter, and it outputs a list of polarity scores. And these polarity scores here, as you can see, are floating 64, okay? And the code itself is in Rust. As part of this code, though, what I'm calling is this thing here, beta sentiment, okay? So this is something that's already been written. It's a library that's, I think, originally written in Python, but it's been converted into a number of other languages. And so I've compiled this. I've loaded this up into the database system, this function. And there, within the single store environment, there's a kind of a virtual machine where I can execute this code in a safe and controlled way. And so I can treat it like any other UDF or any other sort of SQL function. And so if, there we go, let me just go down here. This piece of Rust code, it's called sentiment table. One quick way to test it is just simply to pass it this kind of parameter here. And like I said, remember I said that it'll take a string and then it will output some scores based upon that. So I'm simply passing in this phrase here. The movie was great. Let's see what it makes of that. Okay, so if I execute this, and it comes up with 4 values here. There's a compound score, and then it's got positive, no negative, and neutral here. Okay. The thing with Veda is that it can take into account a number of things, like emojis, for example, or if you use capitalization or exclamation marks to kind of emphasize something. So here below, I've got exactly the same thing, but I've got the word great in capitalization followed by an exclamation mark. That can make a difference. So if I run this now, and I look at the scores, my scores are actually different. Okay, if you again just compare this, you'll see the positive is stronger, the neutral's gone down. Obviously, there's no negative element here. Okay, and then finally, we can actually use this in a more meaningful way. I've got a large movie review data set that's already loaded into my database system. And then I can just run this little bit of SQL code here that will execute that sentiment table function across that data. And so what I can do is, it's because of the space there, I'm not seeing absolutely everything, but here you can see a part of the sentiment that was conveyed. You can see it's kind of chopped off at the end there, but I mean, it's limited in terms of what it's demonstrating. But again, I've got positive values, I've got negative values, in this case 0, and so on. Okay, I think I can scroll a little bit to the right here. Neutral seems to be very strong in a lot of these cases. Quite high values, 0.7 and 0.8 typically. So people don't seem to have overly strong opinions here for these particular movies, or at least this kind of small set of examples that's come through. Okay, great. So let's just wrap up then, and let's see if I can get back here and get back here. Okay, so just to summarize then, and we'll wrap up there. Adopting single store is very, very easy. I mean, it is something that you can combine with a range of other technologies, augment, modernize, replace. One of the things that I found through my life and my IT career, it's very rare for companies to do the kind of rip and replace kind of thing. You know, often they'll implement something in parallel. Eventually, something gets replaced. Greenfield developments are very rare, but often, you know, companies do need the means to be able to work with a lot of modern technologies, and the demands are such that, you know, you've got deregulation in many industries. There's pressures in terms of being able to deliver products and services much faster, and these are quite challenging demands. And so single store, literally the name single store, can replace many of these other technologies. And here are just some examples of some of the customers that have done so. There we go, and thank you very much. Okay, so if you're interested, create a free account for the trial, cloud trial, singlestore.com/cloud-trial. Okay, let me just highlight that for you. over this side. If you would like to download and just to install it yourself, like I said before, there's a 4-node version that you can get. And we can happy to take a couple of questions if we have some. We've got a little bit of time.